In 1374, the gravely ill Sultan of Mali fell into a torpor from which he would never recover. His death was the first to be attributed to what would become known as sleeping sickness. Between the 14th and 19th centuries, sleeping sickness became increasingly common. At the end of the 19th century, the first major epidemic struck Uganda and the Congo Basin. Historians believe 1 million people died. Meanwhile, colonization, which resulted in deforestation, road construction, and population displacements, all contributed to the spread of the disease. In 1901, English biologists Ford and Dutton identified in patients' blood the cause of the disease, a parasite called the trypanosome. In 1903, a British physician, David Bruce, discovered the vector of the parasite, the tsetse fly. In 1905, tests were performed on the first treatment, atoxyl, a highly toxic arsenic compound that can cause blindness. At the beginning of the 1920s, colonial medicine attempted to eradicate the disease. Eugène Jameau, a French military doctor and director of the Pasteur Institute in Brazzaville, laid the foundations for what came to be called Jameau's doctrine, identifying and treating all possible cases to eliminate the reservoir of parasites in humans. Armed with microscopes, he and his mobile teams traveled to the remotest of regions, seeking out patients they then treated with arsenic derivatives. In Cameroon, between 1919 and 1930, Jameau's doctrine brought down prevalence, meaning the percentage of the population with the disease, from 60% to 4%. In 1949, Swiss chemist Ernst Friedheim came up with the idea of combining an arsenic derivative with an antagonist used against arsenic-based gases during World War II. His drug, melarsoprol, is still used, albeit rarely, in the advanced stage of the disease. In the 1960s, as the colonizers departed from most of the affected countries, interest in the disease declined, and the tsetse fly reappeared. An epidemic broke out in 1970 and reached its peak in 1998. Efforts made since have seriously reduced the number of cases, and the World Health Organization has set itself the objective of eradicating sleeping sickness by 2020. The tsetse fly that transmits the sleeping sickness parasite to humans is found in a vast territory of 36 African countries, with the disease prevalent in 19 of them. Within a country, sleeping sickness affects areas from small villages to entire regions. Rural populations, who rely on agriculture, fishing, animal husbandry, and hunting, are the most exposed. More than 80% of patients live in Democratic Republic of Congo. Central African Republic, Congo-Brazzaville, Chad, South Sudan, Angola, Uganda, Gabon, Guinea, and Equatorial Guinea are also among the most affected countries. The impact of conflicts is manifest in that they disrupt health systems and force people to flee. Uganda in the 1980s is an illuminating example. The civil war in Uganda drove people in the northwest of the country to seek refuge in what is now South Sudan, where sleeping sickness has always been present. Meanwhile, the tsetse fly proliferated on land left uncultivated in Uganda. When the refugees returned home, people who had been infected in Sudan, who had become human parasite reservoirs, brought the disease back into Uganda. In 1986, cases of sleeping sickness soared in the region. In 2009, for the first time in half a century, fewer than 10,000 cases of the disease were reported, but in reality, there were probably more like 30,000. as long as people continue to carry the parasite, the human reservoir won't dry up and the tsetse fly will continue to spread the disease. The danger lies in regions where the disease is considered almost eradicated, as health services may relax their vigilance. The sleeping sickness cycle starts with a bite from a tsetse fly. If the fly bites someone who's already sick, it ingests parasites as well as blood. These parasites, called trypanosomes, accumulate in the fly's gut. 20 days later, they migrate to the tsetse fly's salivary glands and are ready to infect another victim when the fly next bites. The parasite enters the lymphatic system and then passes into the bloodstream and circulates through the body. At first, the host's immune defenses attack the parasite. To shield themselves, the parasites mutate, change form, and escape from the host's immune system, until they're recognized and attacked by another wave of antibodies. This cycle of attack and defense is repeated several times. It's accompanied by symptoms such as intermittent fever, headaches, and joint pain. Symptoms that mirror the inner struggle between the immune cells and the parasites. These first phase symptoms are sometimes too mild to be detected, but this is when it is actually easiest to treat the disease. If it isn't treated in time, the parasites advance to the brain. The blood-brain barrier is there, a filter to protect the brain against pathogens, toxins, and hormones circulating in the blood. But the trypanosomes breach it. At this stage, the disease is much more difficult to treat, as the blood-brain barrier also blocks some drug molecules. If the trypanosomes manage to enter into the brain, the sleep pattern becomes erratic. Infected people develop poor coordination and become confused, alternating between episodes of severe fatigue and agitation. Sleeping during the day, they can't sleep at night. The deterioration of the nervous system leads to coma. Left untreated, sleeping sickness is fatal. At the beginning of the 20th century, Dr. Eugène Jameau began to implement the first strategy to combat sleeping sickness: mass screening. This was an important step, as the first, very long stage of the disease is often asymptomatic. Doctors can make a preliminary diagnosis based on clinical signs, such as enlarged lymph nodes in the neck. To detect the presence of the parasite, a blood sample is taken and examined under a microscope. To know how far the disease has progressed, cerebrospinal fluid is examined. The sample is taken via a lumbar puncture, which is often a painful procedure. The earlier the diagnosis is made, the quicker treatment can be given, thus preventing the development of the neurological stage of the disease, which is much harder to treat. 2 drugs are used to treat patients in the first stage of the disease: pentamidine and suramin. This treatment, given by intramuscular injection, is relatively easy to administer and is effective, but it has major side effects. During the second stage, until a few years ago, patients were still treated using an arsenic derivative that had been used since colonial times, melarsoprol. Although it is very effective, the treatment is very toxic. In 5% of patients, it leaves patients with severe neurological damage and can even be fatal.
I was treated with a medication called Arsobal. The treatment really hurt. It was given intravenously, but it hurt. It burned. When they injected Arsobal, after the injection, we would open our mouths. The heat, really, it burned.
During the 1990s, almost by accident, it was discovered that an anti-cancer drug, eflornithine, was effective against sleeping sickness. It is more effective and less dangerous than melarsoprol, but it is complicated to use. 4 infusions a day for 14 days. In remote areas, it was nearly mission impossible. Many doctors had no choice but to use the old drug melarsoprol. Finally, in 2009, a new treatment developed by DNDi, the Drugs for Neglected Diseases Initiative, was made available. NECT. NECT is a combination of eflornithine and a second drug, nifurtimox. The results are good for the second stage of the disease. NECT is more effective, better tolerated, and requires a quarter of the number of infusions. Today, it is used 98% of the time for patients in the second stage of sleeping sickness.
Currently, sleeping sickness is treated with a medication called NECT, which requires 7 days of infusions, 2 hours per day, twice a day. In addition, there's an oral treatment, every day, 3 times per day, for 10 days. That's a lot of vials and pills to transport for each patient. In total, there are about 10 kilograms of materials and medication per patient. The next step is to find an oral treatment. For the past few years, DNDi has been working on an oral medication. This oral treatment is called fexinidazole. The treatment consists of 24 tablets administered over 10 days. Compared to NECT, it is a real step forward. We are continuing our research to improve and simplify this treatment. Ideally, we would find a medication that is given in one single dose. We're studying one medication, part of the oxaborole family, that would be given as a single dose to treat the whole disease. It will take about 2 years of studies to show both its safety and efficacy. And then we'd make it available to the World Health Organization, and it would become part of the WHO roadmap, which has as its objective the elimination of the disease by 2020.